So hopefully, I don't think anybody will fall asleep. It's a pretty exciting topic. So I started calling him Dr. Phil, but not the Dr. Phil. The other Dr. Phil. Okay. So Dr. Phil Polstra is joining us today from Pennsylvania, Bloomsburg University. Well, it just changed, right? So come over there. And a very cool, exciting topic. I mean, I don't know if I can go a week now without reading something about drones somewhere, about them falling on people. I don't know if you'll probably talk about that, but, and just the general use of drones, the commercial use of drones, the private use of drones, and this topic, which is autonomous hacking drones, which brings up to mind like Terminator movie type stuff. But well, let's get started and give Dr. Phil, a warm round of applause, please.
All right. Hello. Is this one on? Oh, okay, now it is. All right. Well, I'm happy to be here, even if I'm in the sleeper slot. I'm not going to be too particular, but so I want to talk a little bit today about remote hacking drones. Not all drones fly, by the way, but we'll talk about some that do and some that don't. So what is this talk going to be about anyway? I'm going to talk a little bit about how you can do some hacking and forensics with some small stuff. It's small, so you can stash it, and it's also small and low power, so you could maybe run this thing off of batteries for a couple days, which opens up some possibilities. Also going to talk about how you can take a whole army of these guys and put them together and do some really cool stuff. At least it's cool if you're doing the stuff and not getting the stuff done to you and all that. I did want to point out over in the table on the left side, or I guess your right side, I just have a couple little things up there. Feel free to go look at those, poke at those. Just a couple little devices that are brought along with me. I apologize, I would have brought more. I'm in the process of moving across the country, so all my really cool stuff is kind of packed. So, all right, so why should you care about this stuff anyway? Well, I'm going to talk about how you can take these little devices, you can run this nice full-featured Linux distro on them, very flexible. You can go to a pen test with a bag, kind of like my little backpack here, and pack 1 or 2 dozen of these devices in there, configure them per your pen test requirements on the spot, and just hack away. Another nice feature about some of the stuff I'm going to talk about, you can do this remotely. All right, so these devices typically have a range of up to 1 mile. So you can be 1 mile down the road by the hotel pool, orchestrating this whole pen test and just hacking the crap out of your target, okay? Also, you know, if you like that sort of thing, you can fly in an aerial drone and do that as well. All right, so who am I? As I said, I'm in a transition. I'm moving to Pennsylvania next week. I've been programming since I was 8, playing around with electronics since I was 12. Also been known to fly planes, build planes, things like that. All right, so I'm going to talk a little bit about choosing a platform and looking at aircraft usage, what kind of things you want. I'll introduce the deck, which is what I call my Linux distro. Give you a real brief introduction to what can you do with one of these devices, and then get into the good stuff. You know, talk about networks of these devices and how you can work with that. And then at the end, I will talk a little bit about how you can make this stuff more autonomous using things like Python. All right, so what are the goals that I was looking for when I decided to start doing this stuff? Well, I wanted something that was small, something that's low powered, you know, so I can run it off of batteries, something that's affordable. I'm a prof, so I'm poor. Something that's mature. You don't want to be on the bleeding edge when you're deploying this in the field. Something with networking, USB, and a lot of nice input-output options. And the winning platform for me is the BeagleBone Black. The BeagleBone Black is one in a family of boards. If you're not familiar with the BeagleBoard organization, they've been making these boards for a while. And the BeagleBone Black is the latest board that they have. It's small. There's a couple of them over on the table there if you want to see them. Less than 10 watts. That's everything. Just the board itself needs less than 2 watts. 45 bucks, pretty cheap. Gigahertz Cortex A8 processor, half a gig of RAM, and Ethernet, USB, all those good things built in. All right. It looks kind of like this. Again, it's BeagleBone Black, also known as the Raspberry Pi Killer. Speaking of which, I know at least somebody will ask me, because they always do, why not use the Raspberry Pi? All right. Well, there's a few reasons why not. In particular, it's not as powerful, doesn't run as fast, doesn't support Ubuntu. All right. It's got an older architecture that's not well supported. It's not open, and I really like open source stuff. Not as mature. They've been doing this stuff a lot longer. And in the end, you'll end up spending more money if you use the Pi, just because when you add in all the different components that you need to get, it ends up costing you more. It's not as reliable. Again, if you're going to deploy something, you want something that's rock solid. And also, they aren't very energy efficient. All right? Don't have a lot of general purpose I/O, and it's kind of fragile, the design. They have these little wimpy pins instead of nice beefy headers, things like that. Not as compact. So just a couple reasons why I didn't use the Pi. All right. So when it comes to an aircraft, what I was looking for was something that had a nice payload. You could fly it in the wind. A lot of times you get these cheaper quadcopters and things like that. They're indoors only, right? You get 4-mile-an-hour wind and that thing is gone everywhere. I mean, I had a little toy helicopter. It was supposedly indoor-outdoor. I took it outside one time, and it was like really scary because a gust of wind came and took it up over the top of my house, and I couldn't see it. And thankfully, I got it back sort of undamaged. Something that can fly a while, something that will take my BeagleBone XBee adapter, Alpha wireless adapter, and things like that. And again, I'm poor, something I can afford. So for my purposes, I chose this guy. Anyone know what this guy is? Nobody. All right. It's called a quad shot. It's a flying wing that's capable of vertical takeoffs and landings. Because it can be flown as an airplane, it has better payload and it has better flight times, because flying as an airplane is a lot more efficient than flying as a quadcopter. But you take it off and land it vertically. So you can fly it to your target, land it on the roof, hack the crap out of them, fly away. All right, that's kind of the idea. As I said, it's called a quad shot. It had all these nice criteria. You can fly it for like 8 to 15 minutes, which is typically enough. Also, some of the models use XBee. We'll talk a little bit more about XBee later. And that was a good thing. It has a built-in camera mount. And if you get the pre-assembled one that I used, it's about 400, not pre-assembled. If you get the complete kit that's got the radio and everything, it's about 400 bucks. All right, so not too bad. All right, so let's talk a little bit about the deck, your new favorite distro. All right. Originally, I developed this for the BeagleBone, or BeagleBoard XM, which is another bigger board. It's a desktop replacement board. I have one of those running over there. Actually, I have one running in my Buzz Lightyear lunchbox with a touchscreen, and the other one is just there. And later, as the BeagleBone Black came out, I ported it to that, which was a no-brainer. The deck is based on Ubuntu, and It's got good repository support and all those other things that make Ubuntu so popular, right? All right, so what kind of things can you do with the deck? Again, if you just have one device, you can do all your standard kinds of stuff. So what's everyone's favorite exploit in the whole wide world? Any conference you go to, it's going to have it. MS08067, right? So here's just an example of, yep, that's in there. So, I've got Metasploit, you run Nmap, and you're like, oh, look, port 445, do a little fingerprinting, and it's XP Service Pack 2 box, fire up Metasploit, go ahead and load your exploit, and get your interpreter shell, all right? Which is kind of cool if you think about it. It's like I just hacked your desktop with my $45 BeagleBone, and I used less than 10 watts to do it. All right, so. Also, Wi-Fi wireless cracking is getting to be more and more common as part of pen test. So, of course, you can run up AirCrack Suite. You can find some interesting networks to hack. Incidentally, when I do live demos, especially around the universities, I get some interesting results, right? You probably can't read this too well, but it's listing all the previously connected networks from all the clients out there. And I was amazed one time I saw several guys had just a long list of strip clubs. And I thought, okay, that's interesting. So what do you tell your wife or your girlfriend? I am only there for the wireless. I don't know that they even had wireless, but so yeah, AirCrack, you can run that. You can crack passwords using Hydra or X-Hydra if you prefer. You can do a little bit of WPS hacking. What tool do you use for that? Anyone? You guys don't hack wireless? For WPS, Reaver, right? So you can run Reaver, and that works too. You can pwn a Windows box like it's a Mac, all right? You might say, but Phil, that should be pwn Windows like a boss, all right? And here's what I mean by like a Mac. If you guys remember, I want to say early 2012, there was a big thing, 700,000 Macs hacked, right? And all the PC users are like, yeah, we've been telling you that. You should protect yourself. And what a lot of people didn't realize is that it was this Java problem that existed on the Windows machines as well. So just loaded up Metasploit, and boom, you've hacked a Windows 7 box. I don't think you can read it. Yeah, it's probably a good thing, because it actually is a box at my former university. But some other fun things you can do with the deck. You can run Fern Wi-Fi cracker. I don't know if you guys are familiar with it. It's what I call a click kitty friendly tool. You guys ever heard of the term click kitty before? It's a trademark term that I share with another guy in Scotland. We all know what script kitties are, right? Skitties? All right, click kitties are lower than the skitties, all right? They can only hack with GUI tools. They can't download those scripts. They can only hack with GUIs, all right? So Fern is a good click kitty tool. Basically, you just run it. It's written in Python. It uses AirCrack in the background. You run it up. You say, all right, this is what I want to hack. This is the interface. Here's the networks. Hack this one, and it tells you when it's done. It's pretty simple to use. All right, so let's get to the good stuff. 802.15.4 networking, sometimes called XBee, even though it's not technically correct, is a nice way of networking with devices. You can use it as a mesh network. And I'm going to talk a little bit about the basics. of 802.15.4. Some of the hardware involved, some of the simpler cases, like you have two of these devices and you want to talk, and we'll get into the slightly more harder cases where you want to do true mesh networking, things like that. All right. So 802.15.4 is typically used in some low-power embedded systems. There's two flavors of XBee modules that you can get from Digi. Digi's a big manufacturer of these devices. They have the regular ones that are good for about 300 feet, and then they have the pro versions, which are good for about a mile. Right? They have two different modes of operation. You can use AT commands. Some of you might be old enough to remember AT commands with your Hayes-compatible modems. I see a couple thumbs up there. All right. Or you can use an API mode. It's relatively low speed, 250 kbps. Supports multiple topologies such as peer-to-peer, star topologies, and mesh topologies. Digi makes a whole bunch of these guys. This is just showing you some of the different options available. You probably don't want to use all these. You probably want to stick with just the 2.4 gigahertz models because they're legal in every country. So you would travel a lot. You might rather use those than some of the other models that, some of them have ridiculous ranges like 16 miles, but you can only use them in the US, things like that. So the hardware that I'm using is made by Digi. It's a 3.3 volt device. If you have a regular device, it'll consume 50 milliamps at 3.3 volts. And if you get the pros, 295 milliamps. So it's a huge difference in power usage. One thing that's a little bit annoying about them, they use 2 millimeter pin spacings. Even though they're made in the US, they're made up in Minnesota. Some of you may know, most devices in the US use 0.1 inch or 2.54 millimeter spacing, so you typically have to get an adapter for that. There's two basic families of these, Series 1 and Series 2. It's very inventive naming. Sometimes the Series 2 are called XBee devices. The difference is the Series 2 devices can be used for mesh networking, and the Series 1 devices are a little bit simpler, and you pretty much use those for peer-to-peer, star topologies, things like that. So slightly higher power consumption on the Series 1. Nice thing about it, though, is it works out of the box, especially if you want to use it in what they call transparent mode, where you essentially take two of these devices and replace a serial connection. Right? Very easy to use. Series 2 can do mesh networking. You don't have to do mesh networking, but it's available to you. One downside of the Series 2 adapters is you have to load the firmware and all the devices saying, this device is a router, this device is an end device, this device is a coordinator. Right? If it's a end device, it gets to go to sleep. If it's a coordinator, that's not so cool if your network coordinator decides that it just wants to go to sleep and things like that. So, all right, so the simplest case, you can take two of these guys and hook them together and replace a serial connection. Right? So before you can do that, you have to configure your XBee modems. Now, Digi provides some software, it's called XCTU, that you can use for this. It used to only run under Windows, and they recently released a Mac version. Also, it runs great on Linux under Wine. I use it all the time. There's also another alternative out there, which honestly I don't really use, but it's out there as well. So here's how this works. If you have an XBee modem, which was shown in the previous picture, you'll see a couple of them on the table if you want to look. You put them in a USB adapter, you plug it into your laptop or your desktop, you run the software, and you just configure it. Right? And you have to tell it a couple of things. like what speed will it talk at. Now they come out of the box talking at, leisurely 9600 baud. You probably want to jack that up a little bit. And if it's a Series 2, again, you have to tell it what it's going to be when it grows up. And you have to give it what's called a PAN ID, a Personal Area Network ID. Right? So 802.15.4 is part of the 802.15 series. You probably are familiar with 802.15.1, also known as Bluetooth. And that's another personal area network. So personal area networks tend to be more flexible, but not as fast as some other networking. So you can pick a PAN ID, you can get creative. You can use 1337 or maybe just 337, if you feel extra special. Or you can go with the defaults, unless somebody's using XBee at their facility. They probably won't notice it, which is another advantage of using this for your command and control. For most people, even if you run around with a wireless analyzer, you're not going to see it. Operates on different channels. It's just noise. It's just stuff that's out there. So you can pick a destination address, 1, 0, and you set your personal address to the other address, right? Pick a number, pick two numbers that you like, and then you just write that information to your modems, plug them into your devices, and pretty much you can talk. All right, and here's a screenshot. What does that software look like? You pretty much, you plug it in. You can say, please tell me what's on this modem. How is it configured right now? And you can kind of go from there. All right, so by default, these adapters work in this transparent mode where everything that comes in on the wire is just sent out wirelessly and vice versa. So if you want to talk to your hacking drone, you can set up TTY on the drone and just log in, right? A lot of people are like, TTY, what's that? Some of us remember dumb terminals, logging in, things like that. All right. Nice thing about this, it's simple. It works with interactive programs. And another advantage, if you go out of range, like let's say I have my laptop here and I'm connecting to a drone, and then I go away and I go to lunch. When I come back, I'm still logged in if I use this method. Right? So how do you do it? On your drone, you have to tell it to do TTY because most Linux systems today don't do that out of the box for good reasons. All right? So basically, if you just cut and paste the stuff here on the screen into a file in etc init, right? And call it TTY02, that's a capital O, not a 0. And you put this in there, and you can run it by saying start or sudo start if you need. TTY02. Boom. Okay, now you got a terminal. Now you can log in using the XBee link. Right? Very easy to do. I'll show you a little bit what this looks like later. Well, what if you want to have more than one drone? I mean, you might think, well, gee, Phil, one drone, that's kind of, an army of one. That used to be a saying, I guess, but not a good saying, but a saying. So you might say, well, I want to have more than one. Okay, you can still do that. And basically what you do is you just set different MI addresses for each of your drones, and then you set the same to address or destination address for all of the drones to say 0, which will be your command console. And then how do you switch back and forth? Well, you have to enter this command mode, this AT command mode. So how do you do that? Well, you hit enter, or you hit plus 3 times, and you wait until it says OK. And then you send it some commands, such as ATDL, and then the name of the drone you want to talk to, its address. Then you write it with ATWR, and then you say ATCN, which means please get out of this command mode because I want to talk to my device. You can also talk to more than one device at a time if you want to use this API mode, which incidentally is what I recommend. The nice thing about the API mode is that it will put all of your data in packets, right? So if you have a malformed packet, it gets ignored. So if there's any kind of noise, some of you may have used wireless dumb terminals before, and you'll notice that sometimes you get crap that comes up, or, you know, maybe some of you didn't do that, but I'm sure at least one of you has ever used a BBS. So you're probably used to some random noise occasionally coming up, and that eliminates that. Performance is a little bit better. We'll give you a tip though. Make sure that all of your modems are in one mode or the other mode. I spent a couple hours tracing down a problem which I thought was with my code, because I'm like, why is the lights blinking but it's not getting anything? It's because that guy was set into API mode and the other guy wasn't, so it dropped everything because it wasn't in a packet. All right. So once you do this, then you probably want to talk to your modem somehow, to your hacking drone somehow. You got a couple of choices. You can use Java, you can use Python, which is what I did, or if you really don't like yourself much, you could send raw data to the port, right? If you got a lot of free time. So really, for each of the drones thinks they're the center of the universe. It's like children, right? I am the favorite. They don't know about everybody else. They just know they're talking to the command console. All right, so if you want to use Python, which is what I did, basically what I have is every drone has a little process on it, and that process just sits in and listens for commands from the command console. All the stuff that's done is logged, all the communications back and forth. There's a facility for announcements. There's also a facility to send small files. So let's say I want to send a new script to one of my drones. I just do it. Code for this available on my GitHub, which is referenced here. You can also go with true mesh networking. You know, there's a nice hotel a mile away, but there's a nicer hotel 2 miles away. So I'll just drop a couple of routers in between. You can do those sorts of things. Here's the thing that's cool about it. There's no software changes, all right? All that has to change is you have to configure the modems, all right? Your software doesn't care. Your drones don't know that they're running Series 1 or Series 2 stuff, that they're in a mesh network or a star network. They don't know. They don't care. It's all the same, all right? All right, and when you do that, as I said before, at least one of these has to be a controller, and you can have routers. The nice thing about the routers is you can have them standalone. You can get a battery. You can hook it up to one of these routers, throw it in a bush outside of your target. You know, if they're really far away, just, you know, breadcrumb trail back to your hotel. Maybe all the way back to the pool. I don't know. Depends on where you want to be. It's nice, though, to have this remote ability. It's also nice because, you know, these drones don't ever go to sleep or have to go to the bathroom, have to eat, or any of those things. All right, so when it comes to building drones, pretty much you need to put together some hardware. So here's an example of an XBee module on top of a BeagleBone Black using a little homemade adapter. If you want to get a copy of the deck, it's available on SourceForge. There's the link for that. Just a little note, if you get it off of SourceForge, I did an apt cache clean on it, which saved about 1.7 gig of space. More importantly, 1.7 gig you don't have to download. When you download the archive, it's already big enough. Get yourself a nice fast SD card and use the script provided, and you're in business. Or if you don't want to do any of that, there are a couple people, including Specialty Computing, that'll just sell you one that's pre-made. Right? You want to power it. If you look on the table, you'll see I've got some pretty basic power supplies, just a few components. Here's some pictures. So the white cable is just a USB cable. So if I want to attach one of these to the back of a desktop somewhere, I can leach power off of it. I can also use batteries, wall warts, things like that. If you want to use batteries, D cells are your best option. You can run this thing for better than 2 days off of D cells. So 4 D cells, or if they're rechargeable, 5 D cells. All right. And here's just a couple of 802.15.4 adapters on various Beagles, including some of the older Beagle bones. And that looks like a repeat slide. All right. As I said before, the adapters, you need to have an adapter in most cases because the pins are a non-standard pitch. So you can buy these from Adafruit is a good place. You're going to need at least one USB adapter so that you can connect it to your laptop. If you're going to wire up your own adapter, it's not that hard. All right, you can just connect 4 wires. And I've got instructions up on the GitHub for this. And then you have to tell your BeagleBone, hey, here's how to use these 4 wires. Actually, 2 wires, because 2 of them are just power wires. All right? And here's how you do that. So what you do is you connect your XBee to the 4 pins listed here on the expansion headers, and you can have a little script like this that just echoes the value BBUART2 into a certain file, and that tells the BeagleBone, hey, somebody has installed something on this particular UART, this particular serial port. All right. Put that in a startup file, and it restarts every time you reboot. If you don't want to solder 4 wires, you can get a CAPE, which is an expansion board for the Beagle. You can just plug it in. I have designs for that available, different forms, including the miniature form if you just want to, make it really simple, but you don't want to really solder. I'm also working on what I call the Ponage Cape that combines XBee, networking, wireless, and maybe some other stuff. Also looking at ways to add functionality. Like if you look at the current aerial drone that I have, it actually doesn't use the BeagleBone for flying, but I would like to change that because it'd be more flexible and stuff like that. And of course, everyone needs a nice container. So if you look on the table, you'll see some of these containers, including my Buzz Lightyear lunchbox. Why Buzz Lightyear? I'm going to hack you to infinity and beyond. That's why. All right. So here's a picture of my Buzz Lightyear lunchbox, which is currently running over there. If you want to plan a device, say behind someone's desk, something like this works well. You can get this little USB hub, or actually this is a network hub that can be USB powered. You can see it's pretty small. And here's a picture of it next to the BeagleBone. Just plug it into the back of someone's computer, leech off power for the BeagleBone, leech off power for their for the network hub, plug it in line to their networking that exists, and you're good to go. All right. If you want to do the air deck, if you want to do the aerial drone, it's pretty simple, and there's a couple ways you can go. If you just want to have a router to extend the range, if you buy an XBee board from Transition Robotics that make the quad shot, you can just do that. You don't have to do anything. Or you can put a full-blown hacking drone on it. And basically, I'll just quickly go through the steps. You take the lid for the brain box, the little board that runs the quad shot, and you put your BeagleBone on there, you line it up for the holes, you drill the holes, take it off before you drill more holes, and then on the inside, you put in the innards of an alpha adapter with some more holes, and then you get something that looks kind of like this. And then you're ready to go off and fly and pwn away. All right, so what kind of things can you do? Simple cases, network attacks. If you have just one drone, you want to do stuff remotely, you know, it allows you to hack from a distance. You can do that. Again, you could use Series 1 adapters. Super simple, not a lot of setup. You could go with multiple drones. So if you're just going to use 2 drones and you're going to use TTY mode, just get your favorite terminal program, run it up. And again, like I said before, here's an example. It's probably hard to see for you guys, but I'm actually running commands on 2 different drones, and I'm using that +++, ATDL commands in order to switch between the different drones. All right, when you're running the Python stuff that I wrote, what happens is I bring up a window that's your command window, and you can send commands to your different drones. And if you want to switch drones, you just start your command with colon and then the number of the drone. And it will bring up a separate window for each drone that has all of the output from that drone. Right? This is all logged. I'm using an advanced facility to display this stuff. It's called Tail. Has anyone ever heard of it? All right. I know it's kind of stupid, but it works, right? You know. And it has the advantage that I log everything as well. So here's kind of a zoom in, just showing you what the command console looks like. And here's the results window for one of my drones. All right. If you want to build the air deck, you can fly it in. As I said, you can use it just as a router to extend the range. Land it on the roof, you know. And here's my recommendation. If you're not a very good RC pilot and you crash the thing, you can probably get away with going and saying, hey, I'm real sorry, but I kind of crashed my toy on your roof. Can I go get it? And most people are going to say, sure, no problem. And while you're there, what are you going to do? Case the place. Gather some more recon for some social engineering later, right? But you probably can't crash it there like a couple of times. They might start getting suspicious. But also, maybe you have a pen test where there's not good availability. You can't get physical access. You could just fly in the one drone. Again, if you crash it on the roof, do your pen test, then tell them about it. Oh, yeah, I crashed that. Sorry. Other things you could do. You could put a high-powered Pro XBee adapter in the aerial drone, and you could use the nice low-powered XBee adapters for other drones, maybe peppered in the bushes around your target, things like that. That way they don't use as much battery power, and you can fly the drone in and out. All right. And the last little bit, I want to talk about how could you automate some of this stuff with Python. And I realize that some of these slides are going to be a little bit hard to understand. All this stuff's available on my website, also in my book. But so, you know, basically you want to start out first by saying what's out there. Now, personally, I don't like complete automation. You know, I had a hacking class I taught once where I had a student that took down the target for a test. I'm like, what did you do? And he said, I don't know, I just clicked, right? He was running Armitage. He had no idea what kind of attacks he was running. He just clicked, right? It's like those Wi-Fi pineapples. It's like, I can't think of a use for those because why would you just want to attack everybody, you know? Usually, if you're doing authorized pen testing, you probably have a specific target in mind. But anyway, so this is just a basic script that uses XBee. It's just a few lines long, and it will run for a minute, and it will tell you, here's all the networks that I found. All right. Anyone use XBee? You guys familiar? A couple of you? Yeah. It's a nice Python tool. Some other things that you can do. You can capture some packets. Again, you can use XBee for that. And a script to do that looks kind of like this. You just import XBee. import the option parser. How many of you are Python programmers? A couple. How many of you read T.J. O'Connor's book, Violent Python? Right. Good book. It's a little plug for TJ, but also another good source for Python. If you look at SecurityTube or Pentester Academy, they have an awesome Python class. Both of those sources will tell you a lot about how to use XBee. All right. So I'm basically coming up with a client list and a packet list. You define a packet handler function. So every time it receives a packet, it just calls that function. And in that function, you do things like decide whether or not you're going to log it. All right? So here's a pretty basic capturing function. Now that you've figured out what wireless networks are out there, of course, you're going to do your standard stuff. You're going to hack into them. Once that's done, the next question you're going to ask yourself is, what's out there? Right? And what's the go-to tool for that? Pretty much Nmap is a good place to start. There is a Python module for Nmap as well, and this little script here on this slide and the next will actually use that Python Nmap module, and then it will store the results in what's called a JSON file. Who's familiar with JSON? JSON, yeah. Very popular with web developers. It's JavaScript Object Network format, I think, something like that. But it's human readable, also very popular, and of course, Python library for it. So what I do is do an Nmap scan, take those results, store it in a JSON file, and then use OpenVAS, which is a open source equivalent to Nessus that doesn't have all the licensing hassles and things like that. And then I'll run an OpenVAS scan on the interesting things using the Nmap results. All right. So this is a nice little simple script that I wrote that'll do that. All right. And okay, so that one's maybe 40 lines long. All right. Other things you can do, you can of course fire up Metasploit using the command line. I'm guessing most of you are familiar with Metasploit. And the general format, if you're going to use the command line, is you just run it, you give it your exploit, you set some parameters. You're almost always going to have to set a host parameter and set some options, run it, and just run it. All right? Set your payload, run it, get your shell and all that. Okay. So some future things that I'm looking to do, I haven't stopped working on this. I've been working on this for a couple of years now, but continuing to add more packages to this platform. Right now there are over 2,000 in the current version of the deck. Going to try to do some more optimization for the Beagle platform. Expand the 802.15.4 code. I've already done a little bit of that with things like the ability to upload scripts, download scripts, things like that. Looking at some other output options. Also looking at exploiting the USB on the go functionality. And as I said before, I want to replace that autopilot that's found on the quad shot with a BeagleBone Black for a couple of reasons. I don't want the extra weight, the extra power, but the BeagleBone Black is a lot more powerful than the little board that's in there. All right, so I want to get a lot of autonomy on my drones to where I can put a GPS in there and I can say, hey, fly this drone over here, maybe circle this coordinate at this radius, and just be done with it and not have to worry about actually flying the drone. All right. I'm actually an okay pilot. I have a couple of thousand hours and a dozen ratings, but I suck at flying RC. I'll admit it. So I've crashed my drone a few times. So it would be nice to have some automation there. Some other stuff that I've done a little bit of work with is using a XBee gateway to extend your range. Literally, if you have your XBee gateway device within the mile, and maybe you're leeching off someone's free Wi-Fi, say, I can hack from another country, really. I can get somebody to go drop my drones around your building and come back every couple days and replenish the batteries, and I could even be here in Hawaii and hacking you in Pennsylvania. All right. Just another note, all this stuff is in a little plug for my book here. Okay. In this book, which is not quite out yet, so that's the bad news. I don't have any to give away, but everybody wins because the publisher gave me a discount code for 30% off of this book and any other book from Singress. So I don't know if that necessarily is going to give you the best prices, but let's say you wanted to buy some other books from Singress. There you have it. All right. And with that, if you have any questions, and if you don't get your questions answered now, feel free to track me down later, or I've already seen other speakers whoring themselves out for Twitter followers, so you can follow me, Polstra, on Twitter. Yeah.